already talked about KU, and KU is in Lawrence here, and we had one of our biggest events in recent memory happen by Lawrence. Lawrence seems to be the common theme in these talks here. We'll be talking about our tornado, which really could have been a meteorologist's worst nightmare, and thankfully it was not nearly as bad as it could have been, and we'll go over that here in the next couple of slides. Just some real quick facts about the tornado. It was actually two tornadoes, we later determined, with a combined path length of nearly 40 miles. The widest point of the tornado was over a mile across in some spots, and the peak ratings for the two tornadoes, one was EF2, the other was EF4, and as anyone who's done storm surveying can tell you that those damage areas at the highest levels were confined to very small locations. The majority of the damage was EF1 to EF2. Time on the ground, an impressive 71 minutes, and this was continuous. Both tornadoes were in existence for a short while, so it was a 71-minute continuous time tornado was on the ground. And from a historical perspective, here in eastern Kansas, this was the strongest tornado in Leavenworth County for at least the last 50 years, and in Douglas County since 1981. So a very impressive event, a really rare event for us out here in eastern Kansas. We usually don't see these strong tornadoes like this. Usually you see them out in central and western Kansas. And I said how close this was to being a meteorologist's worst nightmare, and this tornado literally threaded the needle between several different cities, and you couldn't have done it any better, quite honestly. It missed Lawrence, the southeast corner of Lawrence, by only about a half mile, and it just barely missed a densely residential populated area. As it went on to the northeast, it missed Eudora by about a mile and a half, and then missed the town of Linwood by less than a half mile. In fact, the very western side of Linwood, got clipped by the EF0 type of winds with the tornado. And then it ended just to the west of Bonner Springs there, and again, another suburb of the KC metro area. And had this tornado continued, this would have been just a horrible event for the northwest side of Kansas City. It would have gone into the Kansas Speedway area, Legends Mall, a very densely populated, business area. Would have gone to the northwest sides of the Kansas City metro area, and then off to the northern side of Kansas City. And if you look just to the outside of that plume, you can see the Kansas City International Airport up there, and it could have easily recurved up into that neck of the woods as well. So we really flirted with a potential disaster here with this tornado. Now, thankfully, from a meteorological perspective, this event was really well forecast in advance. We were talking about the potential for severe weather for 5 days out, including the potential for strong tornadoes. And just to show here, this was the SPC Day 1 outlook that came out. And we were in the edge of a moderate risk with a hashed tornado outlook. I mean, everything was pegged and it looked like a solid outbreak. However, as the day unfolded that morning, we weren't exactly sure what would transpire. We had morning convection ongoing across northern Kansas that really put a bit of a question mark on our forecast. Will we see recovery in the afternoon? The upper level pattern, just a quick look, pretty classic severe weather setup, broad long wave troughing across the west with an embedded short wave lifting up through the southern plains region towards Kansas, and these are images taken at 21Z. From a surface analysis standpoint, we had a surface low pressure across western Kansas with a stationary boundary arcing to the east northeast, and we did have a residual outflow boundary sitting up across the I-70 corridor through Topeka, and Lawrence here is at that yellow star area. So from a synoptic standpoint, we were looking pretty good. It was just a matter of would the environment recover in time. Again, here's 21Z just from a Cape shear standpoint, plenty of instability. And this is the helicity plot here on the right. Now, keep an eye on those values. We're going to go into a little bit about those helicity values here in a little later in the talk. We would think 250 is plenty sufficient for tornadogenesis, but when you did a near storm environment analysis, the helicity values were changed quite a bit as the storm approached. And I apologize if this loop's a little jerky. This was the GOES 16-day cloud phase RGB plot. Early on, you can see those low clouds that were hanging around across the area, and actually there was a residual gravity wave that was moving across. You can kind of pick it out there through Osage, Coffee County, and it was on the backside of that gravity wave that we first started seeing the signs of trouble there between 19 and 20Z as we started seeing the first convective towers going up across Butler and Greenwood counties there. Those storms continued to develop and mature, eventually congealing into more of a multi-cell embedded high precipitation supercell type storm mode. And our first tornado warning went out at a little before 4:40 p.m. And we had a brief tornado touchdown reported south of Osage City in Osage County. This is just a picture of what we believe to be is that tornado by some storm chasers out in that area. The storm continued to move off to the northeast and really didn't change a whole lot in structure until it got towards the Osage-Douglas County border, which is just to the southeast of Topeka. And the first tornado formed, the first of the two tornadoes formed at about 5:49 p.m. Central Time with 2249Z, about 2.5 miles southeast of Overbrook. And it continued moving off to the northeast. You can see a pretty standard looking couplet there, nothing too extraordinary, but definitely a couplet visible moving off to the northeast. And one thing to note right away is look how embedded that circulation is in the rear flank downdraft of the HP supercell. There is no way anyone's going to be seeing this tornado until it is right on top of them. And in fact, we found a video from a storm chaser here in the bottom right-hand pane that was taken, from what I can tell, a minute or so ahead of the tornado. And the tornado actually hit these trees right here. I was actually able to identify these trees that were hit. And there was just, there's no way you could have seen that tornado coming, and he didn't even know it was behind him, honestly. And this small tornado continued off to the northeast, and it actually began to weaken based on the damage survey and even the radar data. You can see as it moved on, the circulation itself began to weaken. However, the mesocyclone itself regenerated to the north, and you could actually see a rear flank downdraft surge coming around the backside of that mesocyclone and lent just enough support to re-intensify that tornado during the latter parts of its life cycle. And you can see some of the tree damage down here, solid EF1 tree damage occurring during that re-strengthening of the tornado. Now, unfortunately, it was during this re-strengthening phase that we saw the vast majority of the injuries occur with this tornado, and that was due to a storm chaser tour group that just unfortunately drove into the path of the tornado. Again, rain wrapped, very, very small on radar. It was just a really bad place to be in the rear flank downdraft of that storm. And we had 12 injuries as a result of that. And something that's not been discussed so much is we almost had a second event happen with another storm chaser tour group just about a mile or so northeast of that spot. And this is a video still capture of that tour group in the blinding rain as the tornado just appeared like a ghost in front of them, and they only missed it by probably 400 or 500 yards at best. And again, the tornado was accelerating at this point. It was probably going at about 40 to 50 miles per hour. Very dangerous in the rain that we just wouldn't have wanted anyone to be close to. And then this is where it gets interesting from a meteorological perspective, is what did the two tornadoes actually merge? This is an example of some radar images from that. This is early on. The first tornado is sitting down here in the black circle, and the redeveloping mesocyclone is here just to the north. And at about 6:05 p.m. Central Time, or 23:05Z, there were two circulations going on side by side, and we did find two damage paths coincident with that. And those two circulations were drawn together and eventually formed into a single entity. And so from a radar perspective, it looks like these circulations merged together. The ground survey was a little less conclusive about that. There were definitely two damage paths coming together. However, the tornado number 1 damage path really was weakening and broadening out as it got closer to tornado number 2. And when we crossed this road here in the middle of the image, there was definitely a very broad damage path there on the south side of this damage swath, and a more intense damage track on the north side, indicative that the two tornadoes were probably coincident in this general area. The problem becomes, were they coincident in the same time space? And that's something we don't know 100%, especially that radar beam in those images is at about 4,000 to 5,000 feet above ground. And so do we know for sure if the two circulations merged? Not 100%. However, the tracks are, for the sake of sake of time, is they were coincident and they were continuous in their damage path. As I said, there was no visual record of the tornadoes at this time, and there was really just no damage in these trees to the south of the tornado number 1 to tell where it went. So the ground survey was less than conclusive, unfortunately. And for those of you who are storm chasers, you may have heard tornado number 1 garnered a lot of attention in the meteorological community for how it behaved. And we'll go into some of the unusual traits about it here in the next couple of slides. First of all, just a quick look at a typical supercell tornado track. You tend to have your first tornado mesocyclone form. It moves off to the northeast, and as it occludes, it makes a left-hand turn and usually turns to the north, while the second tornado and low-level mesocyclone reforms further to the east. With the May 28th tornadoes, this recurvature never happened. The tornado number 1 continued on its east-northeast heading and eventually merged into the southern side of tornado number 2's mesocyclone, and again, essentially had a continuous damage path. So why did this happen? Well, first of all, we need to ask the question, why did tornado number 1 even form? And that's a question that can be answered in a number of different ways. This is just one possible theory for how tornado number 1 formed and why it behaved the way it did. We actually had a storm merger going on, actually several storm mergers going on with this HP supercell during this time frame, one of which was occurring to the south of the rear flank downdraft. So we had this new cell developing to the south, and its forward flank downdraft impinging upon the rear flank downdraft gust front of that HP supercell. And this was prior to tornado genesis. This is about 10 minutes prior to tornado genesis. If we move forward to the time of tornado genesis, you can see that merger. If you plot that hypothetical forward flank downdraft gust front, it's almost exactly at where the tornado formed on that rear flank downdraft gust front, underneath the low-level mesocyclone, which then amplified that near-surface vorticity and formed the tornado. Now, however, as time moved on, if we go another 4 or 5 minutes into the future, that storm merger continues, and the forward flank gust front would hypothetically be moving further north still. The tornado itself seems to be riding or is just slightly behind the rear flank downdraft gust front of the HP supercell. And actually, it may seem that the merger process disrupted that low-level mesocyclone, and we'll go in a couple of images of that here next. And as time went on, that tornado continued to ride the rear flank downdraft gust front as that merger continued, and basically was kind of by itself. It wasn't really supported by a whole lot in terms of the holistic storm approach. So here is that low-level mesocyclone recycling that I talked about here. Early on in the tornado, right after the tornado was formed, the tornado was located right underneath the mid-level to low-level mesocyclone. Strong circulation center there, nothing really too out of order there. However, as we go about 6 to 7 minutes into the future, note what happens to the actual mesocyclone itself. The mesocyclone becomes disrupted. It becomes more of a broadly cyclonically convergent signature rather than a true rotational signature, and we actually have the tornado just sitting out here on the periphery of the mesocyclone. The mesocyclone might be aiding some support to the tornado, but it's not coincident with the mesocyclone at all anymore. And in fact, we go about 5 minutes into the future, we still have that broad cyclonic convergence signature here on radar. The tornado is actually way down here in the very bottom of that dashed line. It's really hard to pick out, and that's actually when it was producing its worst damage, EF1 to EF2 damage. And then finally, the mesocyclone regenerates, re-intensifies, and we get this more classic cyclonic circulation signature here as the tornado is being wrapped up into it. So we did see a cycling of the low-level mesocyclone. Looking aloft at the mid-level mesocyclone, you didn't really see this. You just saw a continuously, slowly strengthening mesocyclone over the course of these images. So this was definitely confined to the lower levels of the storm. So the takeaways from tornado number 1 were that the genesis may have possibly been due to the interaction of those two southern forward flank gust fronts and northern rear flank downdraft gust fronts underneath that supercell mesocyclone that initially stretched the vortex tube and led to tornado genesis. But then as that mesocyclone degenerated for about 10 minutes, the tornadoes tended to just ride the gust front, didn't really have a lot of support, started weakening, and it wasn't until the low-level mesocyclone re-strengthened and began to pull the circulation back into it that we saw it re-strengthen. And there was some talk in the meteorology community about 2 mesocyclones being present. When you look at it from a holistic radar approach throughout all the depth of the storm, it's really just one mesocyclone. Arguably, it's complex in the low levels because you have 2 circulations, but the diameter of that circulation with the tornado was less than half a nautical mile wide. It's essentially a tornado vortex signature. It's not a mesocyclone. It falls below what we as the meteorology community is setting as the definition of a mesocyclone. So it's more appropriate to call it just one mesocyclone that was complex. So moving on, tornado number 2, after this possible merger, really rapidly intensified. There's no doubt that tornado number 1 lent some sort of component to the rapid intensification of tornado number 2. It's just a matter of how much. Within a mile or so, we were seeing EF3 tree damage here across areas south of Lawrence with stripped tree bark, large swaths of trees down as it moved up and down the hills. Definitely could see a topographical component to the wind damage. You could see it was maximized at the bottom of the hill. And as the tornado rode up to the top of the valley, we actually saw a decrease in the damage. And then as it went down again, we saw an increase in damage. So definitely some topographic variations there. So this is some examples of the tornado as it was approaching Lawrence. The house icon is actually my house because this was a very close event for me. The tornado passed about 3 miles south of my house, and Brian doesn't live much farther away from me here. This is at 6:09 p.m., so 2309Z. And at this point, this very moment, meteorologists here actually had no confirmation that we had had a tornado yet. Tornado number 1 had gone completely unreported by anyone real time to us. And tornado number 2 was just starting to get its act together. And it wasn't until this moment here, south of Lawrence, that we got our first report of a tornado and reissued a new tornado warning with that information. And coincidentally, also had a TDS show up here on radar as well, a very classic tornado debris signature. The tornado continued just south of Lawrence, and as it tracked to the northeast, we were sweating bullets here if it was going to clip the southeast side of Lawrence or not. And in fact, finally at 6:19 p.m., we issued a tornado emergency for the southeast side of Lawrence. This tornado emergency also included Eudora and then was extended by the Kansas City office to include parts of their area to the west of Kansas City. And this is just some examples of what people were seeing out there live in the field. And again, this tornado was just cloaked in rain. One of the best pictures I think I've seen of it is this middle left-hand picture here. You can make out the left edge of the tornado here, where my mouse is, and the right side is somewhere over here. So if you kind of look back at it and squint, you can definitely see there's a tornado circulation right there, but man alive, it's hard to see. And if you need just the right light to see through the rain shaft to be able to see it. Definitely not something you want to be chasing. Now, I talked about the helicity, the low-level helicity that the storm was ingesting, and the SPC meso analysis had anywhere from 200 to 300, roughly 250 in our area for storm relative helicity values. We had the rare opportunity, we had a really dense personal weather station network just ahead of the storm as it was approaching Lawrence. And we went back and looked at this, not in real time, this was after the fact, to see how the near storm environment changed as the storm was approaching. So these are just the wind speeds from that personal weather station network before the tornado formed to the southeast, southwest of Lawrence. Overall, seeing the broad southeast flow, nothing to write home about, pretty standard looking profile there. But as the tornado approaches, look at the backing of the winds as the tornado approached. We saw the winds go from southeast to east-southeast, even some easterly winds there as the tornado is approaching. And this is about 20 minutes before the tornado arrives in Lawrence. And then right as the tornado hits Lawrence, look at how some of the winds are going northeast, just outside of the storm there. Definitely seeing some enhancement of the storm, possibly maybe anvil shielding, possibly just the storm augmenting its environment around it. Definitely seeing that uptick in helicity right around the storm. And if you go and modify the WRAP forecast photographs for that event, what was, still an impressive 283 meters squared per second squared of storm relative helicity jumps to over 400 meters squared per second squared. And this is probably underdone possibly based on some of those wind profiles through the depth of the atmosphere. So really impressive how the storm modified its own environment to enhance and support the tornado. And now, as this tornado approached Lawrence, it was definitely a multi-vortex tornado. These are some of the aerial shots we got after the fact. These are actually visible in Google Earth if you want to look at them. This picture in particular is just south of Lawrence here at this red X. Definitely seeing the multi-vortex signature here. These swirls are only on the order of 700 to 1,000 feet long in their paths before they dissipate. So again, definitely showing how you can have these intense and narrow swaths of damage in the tornado. And also one thing to notice is the tornado made a slight jog to the east just before it reached Highway 59 out here to the south of Lawrence. Had that jog not happened, the tornado would have continued on its northeast heading and gone right into the southeast side of Lawrence, and we would have had a much different talk to present today. Definitely, again, highly populated area. We had a school in this area. You get to the business district on the east side of Lawrence, the county buildings are there, the county jail is there, all sorts of buildings you just don't want to be hit with a tornado. The tornado continued off to the northeast, and again, just clipped Lawrence and moved into the Kansas River Valley. And it was here we saw an impressive strengthening of the tornado here as it went down into this relatively broad valley. And we saw solid swaths of EF3 damage. The trees were just mowed down in the Kansas River Valley. This is a before and after image that I'm showing here of the trees. You can just see how it was just complete devastation of the trees. And we always wonder what would have happened if that tornado had gone through downtown Lawrence and done that. It would have just been a nightmare for us. We would have not been able to comprehend that. The tornado then continued up the river valley, and this is where we saw the one bit of EF4 damage was just to the west of Linwood. Single family home, well-built single family home destroyed. The debris plume was actually scattered almost a quarter to a half mile to the north of that house, as you can see in the debris plume outlined here in the aerial imagery. Also, one of the more the object that the news media focused on was the Free State growers' greenhouses were absolutely trashed by the tornado as it went right over those greenhouses and just obliterated them. Greenhouses didn't stand a chance with that tornado. And the tornado continued off to the northeast, and it didn't really narrow as it began to weaken. It was steadily weakening as it got past Linwood here on a slow but steady basis. But it maintained that almost 1 mile width right up to the very end. It was a very broad circulation as it continued off to the northeast. Again, still producing EF1 pockets of EF2 damage to homes in that area. And these are just some examples from radar as the tornado was dissipating. One thing to note, and I hope Aaron Johnson's on this call, he'll like this, there was a ZDR arc with this tornado as it was strengthening, as it was going through the Lawrence area, as it was crossing the Kansas River Valley, and it's shown here in this upper right-hand image. And about 10 minutes before the tornado dissipated, that ZDR arc just simply disappeared. And you can see the sudden dropout in ZDR about 10 minutes prior to the tornado dissipating. And from a storm relative velocity and CC standpoint, we saw a gradual decrease in the inbound and in the inflow to the storm. The TDS itself also became more nebulous in nature as the tornado was dissipating. And this image is right about the time just before the tornado dissipated, and this is just after the time the tornado dissipated. Again, very much a decaying signature as it got to the north side of Bonner Springs there. And of course, our job wasn't done after the event. We had to go do the damage survey, and we sent out 2 survey teams, one from the Weather Service in Topeka, the other came out from Kansas City, and together the initial results of the tornado were released at about 3:30 p.m. the next day on May 29th. And one thing to note here is it was one track that we put out. And this was the very initial damage survey that was put out. You'll notice, we did definitely survey the areas that were hardest hit and got the initial EF rating right. But notice all the holes in the damage path that could be easily filled in subsequent surveys. And that's what we did here in Douglas County in the Topeka area. We went and resurveyed the entire event several times to try and fill the holes in this damage survey. And within a couple of days, we'd gone out several times, and we found out that we did have a second track there, and we released that information on June 5th that we did have a second tornado, an earlier tornado that was that started earlier in the event. The initial survey had the tornado starting here, and we found it extending all the way back into Osage County, and again filled in all those holes. We also, one thing here is this tornado is memorable for me because my baby daughter was born the day before, so I was in the Lawrence Hospital that day. I wasn't actually working operations. So of course, right after we got out of the hospital, we had to go do a damage survey with a 4-day-old baby. And so this is a picture of my daughter Lily as we went out and did some damage surveys with my wife Andrea. And for those who are parents, know that the first couple of weeks after a baby's born, you're up all the time. So this is an example of sketching out tornado tracks at 4:50 in the morning here with the baby sleeping on the desk comfortably on a blanket, and she's not finding too much at all. So definitely a memorable event for me personally as well. And right after the event, we did order high-res satellite data through the NWS USGS partnership program that hopefully most of you have had a chance to use at some point. That data came in on May 31st and June 13th. And through an analysis of that data, we were able to construct the high-resolution damage polygons by early July for this event, and we're able to then publish them afterwards. And from all that, finally, we were able to create a fairly nice news story about this event using the Esri ArcGIS story map function that we should all have access to through our NOAA GIS accounts. And we were able to use that high resolution data to create an interactive storyboard that is really quite impressive and really immersive for the viewer to use, and walks people through the tornado track. And it's hoped that maybe at some point in the future we can leverage these capabilities to replace or even augment what we do currently through the CMS. It's currently just being explored right now. We're hoping to possibly leverage stuff like this in the future. And with that, that is the end of my section of the talk. And again, if you want to look at the web story, it's on our webpage right now on our top news section. And if you have any questions, feel free to shoot us an email or feel free to ask them at this point.